So here, we have to write recursive and explicit functions for each geometric sequence. And then finally, we have to graph them and label our axes. So if I look here, my first term, a sub 1, is 2. And then here we have a sub 2 is 4, and so on. Now, geometric means I'm going to multiply. So if I multiply, what do I multiply 2 by to go to 4, and 4 to 8, and 8 to 16? Well, you can divide any two consecutive terms. So I'm going to take 4 and divide that by 2. So my common ratio equals 2. So if I look at my recursive rule, I just have to state my starting number. A sub 1 equals 2. And then for a geometric series, my formula, my general formula, is a sub n equals r, the common ratio, times a sub n minus 1. So in here, my common ratio is 2. So we would just say a sub n equals 2 times a sub n minus 1. To get an explicit equation, again, I'm just going to write a general exponential, but this is the first term. I'm going to go back and find the 0th term. So to move to the right of the series, I multiply by 2. So moving to the left, I divide by 2. And for my 0th term is 2 divided by 2, which is 1. So just a reminder, the general exponential is y equals a sub 0, basically, times r, the common ratio, to the n. So y is equal to 1 times 2 to the n. And then what we want to do is just check that out. For my first term, if I plug in 2 to the first, 1 times 2 to the first is 2. Then just check it out for another one. The second term, 1 times 2 to the second is 4. And then all that we have to do is graph the sequence. So I'm just going to write term 0, 1, 2, 3, and then 4. I need to go from 2 to 16, so I'm just going to count here by 2. So on my y-axis, I'm going to go 2, 4, 6, 8, 10, and I'm not going to quite get up to 16. So term 1 is 2. I'm going to place a dot. Term 2 is 4. Term 3 is 8. And then term 4 is 16, which is going to be off the graph. So if you notice, for geometric, you see a curve. So we're going to move on to our next problem, which just says time and number of cells. So as I look here, I notice the first term, I'm just going to write that down, a sub 1 is equal to 3. And then I just need to find, well, what's my common ratio? So to go from 3 to 6 and from 6 to 12, I multiply by 2. So my recursive rule, again, we just say a sub 1 equals 3. And then what we do is just say, all right, a sub n equals 3. Oh, I'm sorry, my common ratio is not 3, it's 2 times a sub n minus 1. And again, one of the things that I do to avoid that mistake, if you notice I did here, but not here, I write down the general formula. A sub n equals r times a sub n minus 1. And then when I say a sub n, that just means I write a little bit lower than n minus 1. All right, so for our explicit equation, we just write y is equal to, and I'm going to put a sub 0 times r to the n. So I have to go back and find the 0th term. So if a sub 1 is 3, a sub 0 equals 3 divided by the common ratio, 3 divided by 2, and you can use your calculator there, and that's 1.5. So my equation here is 1.5 times 2 to the n.